Welcome back to Space Stuff Now. Today we're diving into some incredible space tech, NASA's sr1, the Skyfall mission, and even flight-proven helicopter tech from Mars. All of that is coming up, so let's get into it.
Houston, integrity, good rotation.
The sr1, known as Space Reactor 1 Freedom, is a conceptual nuclear-powered spacecraft architecture designed for long-duration missions. Instead of relying on chemical rockets that burn fuel rapidly, sr1 uses a compact nuclear fission reactor to generate continuous electrical power. This power can run propulsion systems, onboard life support, scientific instruments, and even surface operations on distant worlds. Nuclear systems like sr1 offer extremely high energy density, long-term reliability, and the ability to operate far from the sun, where solar panels become ineffective. While sr1 isn't a flight-ready vehicle yet, it lays out a roadmap for how future deep space missions could be powered. The Skyfall mission concept builds on this foundation. Skyfall imagines a spacecraft that uses nuclear power to drive advanced electric engines, allowing continuous thrust over months or years. This combination of high onboard power and efficient propulsion could send spacecraft to the outer planets, their moons, asteroid belts, and deep space scientific outposts. Skyfall represents the next step after Artemis and Mars exploration, a leap into true interplanetary travel where missions are faster, safer, and more capable. One of the technologies that makes this possible is the same propulsion system planned for NASA's Lunar Gateway, ion engines. These engines work by using electricity to ionize a gas, usually xenon, and then accelerating those charged particles out the back of the engine using electromagnetic fields. The thrust is gentle but continuous, allowing spacecraft to build up enormous speed over time. Gateway will use solar power to run its ion engines, but sr1 and Skyfall would use nuclear reactors, unlocking far greater performance and enabling missions far beyond the moon. Another breakthrough comes from the Perseverance rover's helicopter, Ingenuity. Ingenuity proved that controlled flight on another planet is possible. It demonstrated autonomous navigation, lightweight composite rotor design, high-efficiency solar charging, and the ability to survive extreme cold. This technology could evolve into scouting drones for Mars bases, aerial mapping vehicles for icy moons, atmospheric probes for Titan or Venus, and search and sample craft for hard-to-reach terrain. Future sr1 or Skyfall missions could deploy entire fleets of autonomous flyers to explore alien worlds from the air. Nuclear power is becoming essential for these missions. Spacecraft have used nuclear power before, but mostly in the form of RTGs, radioisotope generators that provide low but reliable power. Fission reactors, like those envisioned for sr1 and Skyfall, offer far higher power output. They can run propulsion systems, support habitats, and operate in regions where sunlight is weak or non-existent. NASA's Kilopower project has already tested small reactors designed for lunar bases, and scaling this technology up is the next step toward nuclear electric spacecraft. When you combine sr1's reactor technology, Skyfall's mission architecture, Gateway's ion engines, and Ingenuity's proven aerial capabilities, you get a vision of the next century of exploration. Nuclear reactors powering spacecraft for decades. Electric propulsion pushing missions to the outer planets. Autonomous drones exploring alien landscapes. This is the blueprint for humanity's expansion into the solar system. From nuclear reactors to ion engines and flying robots on Mars, NASA is building the tools that will carry us into deep space. The sr1 and Skyfall concepts aren't just ideas. They're stepping stones toward a future where interplanetary travel becomes part of everyday exploration.